discussed about the time complexity techniques, and I hope you have revised that topic. And there are different time complexity techniques like big O, theta, omega, and we have measured the time complexity of different algorithms, how to measure the time complexity, what is the measure of exact time and what is the measure of time complexity, or in terms of some asymptotic notation. Then we have given some example how to calculate if a simple for loop running, then order of n, if nested for loop, order of n square. So there are different time complexity which are called constant time complexity, linear, logarithmic. So there are different time complexity techniques. Okay, so we have discussed about all these things in the last class. Now today in the lab class we have discussed about array, which is one kind of data structure, and we have also understand that the different operations that we can perform in a data structure is new element insertion, then element deletion, then searching, sorting. So there are different techniques or operations to perform in a data structure. So today we will start with one particular operation in an array that is called sorting. So we will start today with a new operation which is called sorting. So almost all of you know what is sorting, because sorting means arranging. You are going to arranging the given data. You are going to arrange the data either in ascending order or in descending order, whatever. Okay, so sorting means one kind of arrangement of data so that we can easily access them or easily search them. Remember this. So actually, what is the purpose of sorting? The purpose of sorting is for better access or for better search. That is the main purpose of sorting. See, if your books in your bookshelf are well sorted, well ordered, then you can easily select or you can easily search a particular book. But if it is not in sorted order, it becomes very difficult. So for better access or better searching, we require sorting. See, we know that there is one searching mechanism which is faster, and that searching mechanism is called binary search. And we know that the main criteria or preamble of any binary search is it must be sorted. So what is the main purpose of sorting? The main purpose of sorting is for better search or better access. See, if your element is sorted, suppose your element is sorted, then it is very easy to insert a new element. Obviously, new element will come into this position. Then the next element will come into this position. Why? Because they are in sorted order. But if they are not in sorted order, suppose we have put 3, then we have put 1, then 5. Then if I put now, if I want to insert 4, then I should insert it in this position or in some other position. So it becomes difficult to insert. So if it is already sorted, it becomes easy to access, easy to update, easy to insert, easy to delete. So these are the main advantages of sorting. Now, in our syllabus, there are different sorting techniques. Again, I have discussed in the first class that for a particular problem, there should be more than one different solutions. Okay, now among those solutions, which one is best? Which one will provide us the better time complexity or space complexity? That will be a different thing. Okay, so for sorting, there are different solutions. Number one, the simplest sorting technique is the bubble sort. All of we know this bubble sort. Okay, then the next one, the most practical one. Remember, this one is the most practical one, and most, you can say, we can easily implement. Okay, this is called selection sort. Then there is another interesting sort which we use sometimes and very useful in online system. This is called insertion sort. Then comes some uh, so this three kinds of sorting technique actually falls under, if you remember different types of algorithm, they are falls under brute force type of algorithms. If you remember what is the meaning of brute force type, brute force means where each and every element is compared with other element to get the solution. Then it is called brute force type algorithm. Then comes interesting uh, algorithm which is based on our divide and conquer algorithm. If you remember, divide and conquer. Okay, so this three algorithm based on brute force algorithm type, this two algorithm based on divide and conquer algorithm. There is another very interesting algorithm which is not in your syllabus, but I like to discuss this one. This is called radix sort. This is very interesting sorting. Why this is very interesting? Because in this sorting, you don't need to know the number system. If you have no idea of mathematics, still you can sort the elements. But in this sorting techniques, you must have the idea of mathematics. Which number is greater than which number? That idea you should have for this algorithms. But this radix algorithm or radix sort is very interesting because here you don't need to know any number system. You don't need to know mathematics, which one is greater than which one. No need to understand. Simply you can sort the elements. So this is not in syllabus, but still I prefer to discuss this radix sort. So let us start with bubble sort. We all know what is bubble sort, but I will discuss elaborately what is bubble sort, then what are the best case, what is the worst case. We have already seen in algorithm, there must be three different cases.
What can you show again?
Sorry?
Left part.
Sorry, তোমার কথাটা কেটে কেটে যাচ্ছে।
বাম দিকে আরেকটু দেখো বোর্ডটা, মানে হোয়াইট বোর্ডটা।
আচ্ছা, ঠিক আছে, আমি বোর্ডটা পাঠিয়ে দেবো, চিন্তা নেই। আচ্ছা, আগের দিনে ভিডিওটা কি আমি আপলোড করেছি? আমার মনে নেই, মনে আপলোড করিনি। ঠিক আছে, আমি আপলোড করে দেবো, ভুলে গেছি। আচ্ছা, ঠিক আছে, ওকে নাও। So now we are going to discuss about bubble sort. Most of you already know what is bubble sort, but still I am going to discuss. And we have seen in the last class that for any algorithm there must be some cases which are called best case. There may be some cases which are called, means the arrangement or permutation of the data will give you best case and worst case. So we will discuss about this. So let's start. So let us assume we have to perform bubble sort. We have to perform bubble sort, and we have to perform, say, ascending order bubble sort. Clear? Now suppose this is our elements. This is our elements that we have to sort. So I have taken only 5 elements. I have to sort them in ascending order. Small, then greater. So the concept is very simple. We have to compare the adjacent element. Adjacent means if this is the ith element, then the adjacent must be I plus 1th element. So we have to compare these two elements. Okay. Now, if these two elements are in order, means we require ascending order. If they are in ascending order, then leave it as it is. Otherwise, what we have to do, we have to interchange the position of the elements. We have to interchange, swap. We have to swap the elements. Okay. So here, This 55 and 44, they are not in order. So what we have to do, we have to interchange them. So what will happen after interchanging? 44 will come here, then 55, then the rest of the elements. Okay. So first, if it is an array, then obviously this is the 0th element, this is the first element, this is the second element, this is the third element, this is the fourth element. Okay. So first row, considering this is an array. So we have first compared 0 with 1. Now we will compare this two, 1 with 2. This two will be compared next. Are they in order? No. Then what will happen? This two will be interchanged. Okay. So after interchanging, what will happen? 44 as it is, 33 will come here, then 55, then the rest two elements, 22 and 11. So we compare 0, 1, then 1, 2. Now we will compare 2 and 3, these two elements. Again, they are not in orders. What we will do? We will interchange them. Okay. So after interchanging, what will be the elements? 33, then 22, 55, 11. Sorry, 11. So next we have to compare 3 and 4 position elements. And if we compare these two elements, again, they are not in order. So what we will do, we will interchange them. This will come here, this will come here. So after interchanging, this is your elements. After first set of interchange operation, first change of adjacent comparison. So you can say this is first set of adjacent element comparison. I'm writing it short. So this is the first step. So this is the first step, which is sometimes called first iteration of the algorithm. So after first iteration, the most important thing is you will got one element at its proper position. See, the rest 4 elements are not in proper position, but the maximum one which will get its proper position after first iteration. So one iteration will give you one element in sorted order. So now what you will do, you will perform the same operation for the rest. For this, so what will happen? This two will be compared, not in order, so interchange. 33, 44, 22, 11, and this is 55 already sorted. Next, this two will be compared. Then again, interchange. So 33, 22, 44, 11, then 55. Again, this two will be compared. They are not in order, so interchange. So after interchanging 33, 22, 11, 44, 55, 55. Now see, up to this, within this block, there are 4 elements. So we have performed the adjacent comparison for this 4 elements. So this is your second iteration. And after second iteration, see, this is your sorted element. So after second iteration, we got the next highest element in its proper position. Okay. So again, we have to perform the same operation for the rest, this 3 element. So again, this 2 will be interchanged. So what will happen? They are not in order. This 2 will be interchanged. So 22, then 33, then 11, and the rest 2 are already sorted. These 2 are already sorted. Then this 2 will be compared, again not in order, so interchange. These 2 are in sorted order. These 2 are in sorted order. Now see, we have compared the 3 elements, the adjacent among these 3 elements. So now again another element is in sorted position. So this is your third iteration. The third iteration. After this, we have to perform the same operation for this 2 rest element. This 2 will be compared. Which one? They are not in order, so interchange. So 11 will come here, 22. Then the rest is already sorted, 33, 44, 55. And after this iteration, so this is Fourth iteration, after this iteration, again another element is in shorted position. So now we have got 4 elements in shorted position. Remember one thing, single element is always sorted. No need to sort them, always sorted. So what is the time complexity to sort one element? What is the time complexity to sort one element? Please, anyone?
O of 1.
0, no time. We don't need to check, we don't need to bother about single element. So the time complexity to sort one single element is 0, remember this. But for searching, this is for sorting. For searching single element, what is the time complexity? Anyone?
1.
1.
0.
No. You must have to search, na? You are searching means you are comparing. Whether it is 1 element or 10 elements, you have to compare. So if there is only 1 element, you have to compare once, then you have to decide found, not found. But in case of sorting, single element, you don't need to bother. So that's why in case of sorting, the time complexity is 0 for one single element. But for searching, the time complexity is 1. Remember this. It depends, the time complexity depends on your algorithm. Na? Searching means finally you have to say whether you found or not found. So you must have to compare. Suppose I have 1 element and I want to search 10. So if 10 is not there, then you have to decide, you have to say that not found. So to check whether 10 is present, you have to compare. So that complexity is 1. I hope it is clear. Okay. Mute karo. তাহলে আমাকে আবার করতে হবে। মানে আনমিউট করে ভুলে যাচ্ছি। Okay, now. So this is the total algorithm, or you can say not algorithm, this is one, you can say example of our algorithm. Now from this example, we will try to develop the algorithm or pseudocode. So what we are doing actually in case of bubble sort, we are comparing the adjacent element. How to compare the adjacent element? If A of I is one element, obviously the next one or adjacent is I plus 1, correct? So I'm comparing I with I plus 1. When I'm performing interchange, if I is greater than I plus 1, then only we are performing interchange. This is for ascending order. So for ascending order, when we will go for interchange, if ith element, previous element is greater than the next element, this one is happening, then we will interchange. So this is one type of condition. If this condition is satisfying, then what we will do, we will interchange these two elements. So you can call a function swap, where you will pass the array name and the ith position and I plus 1th position, or you can directly write it in simple code, t equal to, using third variable, t equal to a of I equal to a of I plus 1. I hope you know this, how to swap. Then I plus 1 equal to t. You have to write these 3 statements, or you can call a function swap where you have to write these 3 statements. So this is the thing that you are doing. If first one is better than the next one for ascending order, and you are going to repeat this. See how many times you have repeated this? First, second, third, fourth. So how many elements are there? There are 5 elements. For first iteration, how many comparisons you have performed? 4. Okay, so I have to run this. So I am repeating the same comparison. So I will repeat using a for loop. Okay, and the for loop will start from 0 position. See, 0 is compared with 1, then 1 is compared with 2, 2 is compared with 3, 3 is compared with 4. So your I will move up to 3, not up to 4. So the value of I is less than n minus 1. I hope it is clear. There is no question. Why? What is the value of n? N is 5. So what is the value of n minus 1? N minus 1 is 4. Less than 4 is up to 3. See, I is first 0, then 1, then 2, then 3. No need to move up to 4. So my for loop is I equal to 0, I less than n minus 1, then I plus plus. I have to repeat these things. Okay. So this is for first iteration. Clear? Now this whole thing will be repeated again. So this is your one iteration, 2 iteration, 3 iteration, 4 iteration. So you are repeating the same iteration again and again. So you need another for loop to repeat the iterations. Okay, how many times this for loop is running? See, there is 5 elements. How many iterations you have performed? 1, 2, 3, 4. You have performed 4 iterations. So the loop will start from 0. It will go up to 4 times. That means less than equal to n minus 1. Then j plus plus. I hope it is clear. There should not be any query. Why? Because 0, n minus 1 is 4. J is starting from 0. It will move up to less than 4 means up to 3. 0, 1, 2, 3. See how many times it has run? It is running 4 times. So this is the simple for loop to repeat the iteration. So this is for iteration, and this is for comparison. Correct? Now see one interesting thing. In first iteration, we have performed 4 comparison. In the second iteration, how many comparison? See, 1, 2, 3. So 3 comparison. In third iteration, 1, 2, 2 comparison. In the fourth iteration, 1. So with the increase of iteration, the number of comparison which is performed by this for loop is performing the comparison. The iteration number is, the for loop is decreasing its size. So it is, if you remember, it is similar to the star printing. First line you have to print 4 star, then you have to print 3 star, then you have to print 2 star, then you have to print 1 star. How you can do this? With the increase of row, when we are increasing the row, the column print value will be decreased. So same thing is happening here. In first iteration, we are performing 4 comparison. Then in the second iteration, 3 comparison. So which loop is performing the iteration? This J is performing the iteration. With the increase of J, which one is decreasing? This comparison is decreasing. So what we have to perform? We have to perform here a minus J. So this will become n minus 1 minus J. Okay. So same like the star printing. So this is the whole algorithm of your bubble sort. So again, in a hurry, for J equal to 0, J less than n minus 1, J plus plus. So this is for the iteration. Then inside this, for the comparison, I equal to 0, I less than n minus 1 minus J. Why minus J? Because with the increase of row, we are decreasing the number of column. Remember, if you remember the star print, this will represent number of rows, this will represent number of columns. Okay, so then I plus plus. Inside this for loop, what we will do, we will compare the adjacent element. They are a of I and a of I plus 1. These two will be compared, and then if first one is greater than the second one, in case of ascending order requirement, then these two elements will be interchanged or swap using this function, and then end of the for loop, then end of this for loop. So that's all. So this is our bubble sort algorithm. Very simple. Okay. Now, the next thing that you have to discuss, you have to understand, what is the time complexity of this algorithm. Okay, now to calculate the time complexity, you can take this pseudocode or you can go directly to the example. Okay, either you can calculate the time complexity from the example or from the pseudocode. Okay, now from the example, if I want to calculate the time complexity, so there are how many elements? 5 elements. How many times? First time we have compared 4 times, so 1 less. So if there is n number of elements, how many comparison we have to perform? See, I have told you in the previous class that this comparison is very important. Assignment operation and increment operation among, or the suppose there is assignment operation, increment operation, and there is comparison operation operator. Then remember, this operator will take the most time. So your time complexity will mainly depend on this comparison type of thing. Okay. So how many comparison you have performed for the first iteration? 4 times. If there are 5 elements, then 4 times. If there are n elements, then how many times? N minus 1 time for the first iteration. Then for the next iteration, how many comparison? 3. So n minus 2. Okay, in this way it will decrease, and after sometimes it becomes 1 comparison at the end. See, for the last iteration, how many comparison? You have only compared 1. So this is your total comparison. So from this, you can easily calculate the time complexity. So you can write it, Tn is equal to this one. Okay, from this is the sum of natural numbers. So it will give you Tn equal to, it becomes what? It becomes n into n minus 1 by 2. It means n square by 2 minus n by 2. Clear? Now obviously, which one is greater? N square is greater. I have already told in the last class in Pico notation, there will be no constant term. Okay, so this is n square minus something. So this is obviously less than n square. Clear? So the time complexity is order of n square. Time complexity is order of n square. So this is the time complexity for bubble short. Now from this for loops, you can also calculate the same thing. See, for j equal to 0, how many times this will run? I becomes 0. Then this value becomes n minus 1. So how many times this for loop will run? This for loop will run n minus 1 times. Then j becomes 1. So this value becomes n minus 2. Again, it will start from I equal to 0 and it will move up to n minus 2. So plus n minus 2. So in this way, it will also give you the same time complexity. Order of n into n minus 1 by 2. That means order of n square. Again, see, this is a nested for loop. This for loop depends on n. So time complexity is order of n. This for loop depends on n. Okay, for one value of this, it will run n times. So the time complexity of this for loop is n square. So which one having highest power? This one. So time complexity is order of n square. You can calculate it from any position, either from the example or from the for loop or from simple checking of the for loops, nested for loop or single for loop. From all these things, you can calculate the exact time complexity. So the time complexity of bubble short is order of n square. Remember this. Now the most interesting thing about bubble short, that so this one 44, 33, 22, 11, this one for bubble short is considered the worst case. Remember, if you remember last class, I have told you worst case means for this type of permutation of data, it will take maximum time. So if you are going to sort the array in ascending order, and if your data is totally in descending order, then you require, or you can say that this is your worst case, combination of data. এটা তোমার সব থেকে বেশি টাইম লাগবে, সব থেকে বেশি কম্পারিজন করতে হবে। Then obviously, which one is the best case? If it is already in sorted order, if already in sorted order, যে order আমি sorted চাইছি সেই order এ sorted রয়েছে, we required ascending order, the elements are in ascending order, so we can say this is the best case. Logic clear? Now we have written one algorithm, this algorithm we have written, two nested for loop. Now for this algorithm, if my data sequence is this one, what is the required time? Please calculate. If my data is already in this order, then what is the
5.
time? For
5.
first iteration, see, you have to compare this two. Correct? First you have to compare. Then after comparison, you understood that this is in order. So you are not going to perform this one, but you must have to compare adjacent element. Am I clear? Is it clear? Whether it is sorted or unsorted, until you compare the elements, it is not possible to say that whether it is totally sorted or unsorted. So you must have to compare. So which one is which time you are just saving? You are saving just this time. This interchange time operation, the interchanging operation, that you are only saving if it is already in order. But see, when we already discussed that actual time and the time complexity, they are totally different. So here, if we interchange these three things, it will be like t equal to, so they are simply assignment operator, an assignment operator having the minimum time requirement, because no need to call the ALU. আমাকে arithmetic logic unit এ যেতে হবে না অ্যাসাইন করার জন্য, কিন্তু কম্পেয়ার করার জন্য কিন্তু আমাকে arithmetic logic unit থেকে ডেটাকে পাঠাতে হবে। তখন তোমাকে হচ্ছে সেই সাইকেল গুলো আছে, ফেজ, ডিকোড, এক্সিকিউট সাইকেল রয়েছে, so it requires time. So whether it is sorted or unsorted, you must have to perform this comparison. It means your for loop will run as it is. So if I write the same algorithm, then again for the best case, it will take the maximum time, order of n square. Remember this. So it means for bubble shot, if we write this algorithm, this one, this particular algorithm, then it will give you all the cases, whether it is worst or best or average, you will get same time complexity because we have to compare. But if we modify the algorithm somehow, then we can get better result for best case. See how we can improve the algorithm. See, if the elements are already in sorted, then there one thing we can check or verify. See, if these elements are already sorted, first you compare this two, then this two, then this two, then this two. So this is your first iteration, correct? This is your first iteration. All the adjacent elements are compared. And if after first iteration, there is no swapping, if there is no swapping, then you can definitely say that the elements are already sorted. Am I clear? Is it clear?
Yes, sir.
I am performing only the first iteration. First iteration, if there is no interchange operation, then obviously this one is smaller than this one, then this one smaller than this one, obviously this one smaller than, so this one is the getter. So this one again, next iteration, this one smaller than this one. Then the next iteration, this one smaller than this one. So it is in order. So we have to modify the algorithm. So how to modify? Simply modify like this: I equal to 0, I less than n minus 1, I plus plus, then for j equal to 0, j less than n minus 1 minus I, j plus plus, then if a of I think there is only one, then less than 1 minute is there. So please rejoin. If disconnected, please rejoin. So we are comparing these two. Inside this, what I am doing, I am using a flag variable. If somehow I get into this, means if first element greater than this, I will modify the flag variable. So I am initializing the flag variable inside the first for loop, and then I am performing the swap operation. Okay, and after this for loop, or after the end of this for loop, I am checking the flag variable. If flag variable is still 0, it means I have never entered into this part. This one is never satisfied, so I can break the for loop. Okay, so this is your modified bubble.